Hello everyone and welcome back to the channel. In today's video, we're going to be taking a look at the execution of an end-to-end regression analysis project in Microsoft Excel. We are going to be building the regression analysis model from scratch, so stay tuned till the end of this project. So let's dive right into it. This is my data set and you can see I have the advertising spend for each month and the corresponding monthly sales. So the problem statement I'm trying to address is to find out, can I build a machine learning model which will accurately predict what will be my monthly sales depending on my advertising spend. So let's take a look at this. So this is my raw data. First step, let me copy this raw data so that I can do my first phase of the regression analysis project. The first phase of any machine learning project generally involves the data cleaning, the data preparation, and the exploratory data analysis, where you understand more about your data and then prepare your data for machine learning. So let's take a look at the data. So first, let me select this and let's take a look at the distribution of my data. Click on Insert, then click on Recommended Charts and go to All Charts and click on the Box and Whisker chart. So this shows me with the distribution of my data, and here you can see upfront it shows me I have an outlier. So the lower whisker tells you your minimum value, the top whisker tells you your maximum value. These three lines represent your quartile, Q1, Q2 and Q3, and here you can see I have an outlier. So this is not a desired, so let us try to remove this outlier. Okay, so click on Data, click on Filter, and let us see if I can remove this outlier. Remove this, and now you can see the data set is fairly normally distributed. My advertising spend is fairly normally distributed, where the median and the average also are almost coinciding. So this looks good. Now let's take a look at the monthly sales. Let's go to Insert. Let's click on Recommended Charts, and let's click on All Charts, and let's click on Box and Whisker chart. Here you can see the data is even more skewed because of this outlier. So this outlier is actually skewing my data. So let us remove this outlier and see the distribution of my data. So it is at 50,000. So let's click on this and let us go to this value and remove it. And now you can see the output variable or the target variable also is fairly normally distributed, and the average is slightly more than the median, but still it's fairly normally distributed. So now let us see if I have any more problems with my data. Let's click on this. They all look to be numerical values, except there's a blank value here. And let us see the monthly sales. They also look to be okay at first glance, but there's a blank value here. So since my data is fairly normal, I can feel very confident of filling these blank values with the average value. If the data was skewed to the left or the right, then I would have to use different imputing techniques to fill those values. So let us calculate the average values and then fill them. So let us say equal to average and do from A2 to A51 range, and then let's copy this across. So let's copy this value, Control C, right click, paste as values, Control C, right click, paste as values. And let us format these two values. Select this and select this and right click, format cells, go to number and OK. So now you have formatted these values. Now let us copy this to create first let us rename this as data. And now let us copy this to create your training and your test sets. So in a typical machine learning project, your training data will be 80% of your total data and your test data will be 20%. So there's roughly around 51 rows. So I can use 40 rows as my training set and 10 rows for my test set. Let's create a new sheet. Double click this, rename this as train, and let's copy this data. So let's copy till 40. And let's double check if my data is fairly good. So I'll select both, hit on Insert and click on Recommended Charts. and click on box and whisker chart. And now you can see it shows the input and the output variable are fairly normally distributed. Okay. Now let us explore, is there any relationship between the advertising spend and monthly sales? Because I'm planning to use a regression analysis model. For that, there has to be some relationship. If the relationship is linear, I can use the model. If it's not linear, then I have to explore some other techniques. So let's click on insert and click on a scatter plot. And here you can see it shows there's some kind of linear relationship. So click on this and hit the trend line, and you can see it shows there's some kind of linear relationship. So the regression analysis model is a good candidate here. If there was not a linear relationship, then I would have to use some sort of a non-linear model or a polynomial regression analysis model. I made a video on that on my channel as well. You can check that out. So now let's do the test data set. Let's go back here, copy the remaining rows, Control C, create a new sheet, rename this as test, and paste it here. Let's go back, copy this, paste it here. Okay. Now let's just copy the first header as well. So let's copy this. Okay. Now let's go about building the model. Click on train. I don't need this anymore, so I'm going to delete these two. Okay. And let's go on building the model. So first let me select this data and drag this down to create space. So since I'm building a linear regression analysis model, in this case it is simple linear regression since there's only one input variable. The equation is represented as y is equal to mx plus b, where m is the slope and b is the y-intercept. So let me write m here and b here, and let me assign any arbitrary values. Let's say 1 and 1. Let's name this here, click on this and name it to m, hit enter, and click this value, name this to b, and then hit enter. So now let's try to make predictions with these arbitrary and random values. Predictions. So let's use the equation y is equal to mx, that means the advertising spend, multiplied by m plus b. Let's copy this down. So these are your predictions. Now to proceed further, we have to calculate the regression sum of squared. So the regression sum of squared is nothing but it tells you how much of the variability of the target variable, in this case monthly sales, can be explained by the model. Okay, so this, for that I first need to calculate the average monthly sales. So let's say average monthly sales is equal to average. Let's Control Shift down and close this. Okay, so you got an average monthly sales. Now you can calculate the regression sum of squared by doing equal to open braces, take the predictions, from that subtract the average monthly spend and square it. Okay, double click this to copy it down, and when you sum this, you get your regression sum of squared. Okay, now let us find the residual sum of squares. Oh, I made a mistake here. Okay, I need to fix this. So 1 second, let me fix this so that it doesn't get moved down. So let me fix E3, hit F4. Okay, I fixed it, and now let me fill this down again. Double click this, it's filled down again. Okay, I needed to fix this because when I drag this down, this also moves down. So this is called an absolute reference. I've given the absolute reference for the average monthly sales. So now we are calculating the residual sum of squares is equal to, open brackets, you do the predictions minus the monthly sales and square it. And copy this down. And sum this across. This gives you a residual sum of squares. Now let us calculate the RMSE. The RMSE is the root mean squared error. This can be got by doing the square root of the residual sum of squares. This represents your error. So square root of the residual sum of squares. Now, the goal of the machine learning algorithm is to learn the best values of M and B that will make this RMSE the least. Okay, so you are trying to minimize your error. That is the intuition behind machine learning. So this involves a process called finding the global optima, and this involves using gradient descent. But to do this in Excel, I'm going to show you how to do this using the solver. This involves calculus, but in Excel, let us try to do this using the Excel solver. So I'm going to click on data. I'm going to click on solver. What is the objective? Let me select the RMSE in this case because I want to minimize this. So click on minimum. And then what you want to do is you want to change the cell. So the algorithm will go to all the different permutation and combinations and find out what are the best values of M and B to minimize the error. So I'll uncheck this and click on solve. And it has done this. Click on OK. And you can see it has shown you the RMSE here. Okay. Now you want to see how good your model is. Okay. You want to find the goodness of fit. This can be found out by finding the R squared. But to find the R squared, we have to first calculate the total sum of squared. So total sum of squared is equal to the regression sum of squared plus the residual sum of squared. Okay. Now the R squared or the coefficient of determination can be given by the regression sum of squared divided by the total sum of squared. And this shows you the R squared is 0.86. Now what this tells you is that 86% of your variability in the monthly sales can be accurately explained by your advertising spend. So this is indeed a very good model. And we also saw the proof of that with your correlation graph. Okay. So now let us try to make predictions. Click on test and I can make predictions. So equal to, let us do the same equation, y is equal to mx plus b. So y is equal to the advertising spend multiplied by m, which we have already calculated in the previous sheet, plus b, which we have already calculated in the previous sheet as well. Double click this down and now let us try to see the accuracy. To find the absolute error is equal to absolute value of the predictions minus monthly sales. Double click it to copy it down and find the mean absolute error, which is the average of this. So your mean absolute error is 339, which tells you that for every prediction you get, it will either be plus 339 of the monthly sales or minus 339 of the monthly sales. So this is quite an accurate prediction and your model is quite good. Now let us try to validate if you got your correct R squared. So let us go to the train data once again and let us click on this both and add the scatter plot again. Go to insert, add a scatter plot. Okay. And you can add a trend line again. And let us see, click on more options. Okay. And then let us display R squared here and display the equation on the chart. So you can see here, we have built our model correctly. We have got our M and our B correctly. And this is your R squared 0.862. So this validates your machine learning model is accurate. And it's a very simple model, a simple linear regression. But if you had multiple variables, also this process works and you can apply machine learning and you can build a model from scratch using Excel. I hope you enjoyed this video. Do leave a comment if you found this intuitive and it helped you understand the intuition behind machine learning, and let me know any other videos on data analysis or machine learning that you would find useful and you want me to make. Do leave a like and subscribe to my channel. Thank you.